you know, like in this class, actually, like for you, I think I'm doing most of the time some like interactive sessions basically, right? So basically, I'm doing some kind of like very practical sort of uh, work I'm discussing here. Like I just want to also highlight that you might need to go through the online session that I'm doing for the regular students in order to follow up the basic, technical stuff related to these theories that I'm covering here. So anyway, like in the regular class, currently at the point where I have discussed about the IoT protocols and IoT protocols up to, several protocols we have discussed. So we have discussed almost most of the main protocols that are important for IoT. I have discussed so far. Like for you, I think I also discussed some things about the protocols, but I believe that I did not go through each and every, slide and or like some note as in the regular class. So I think if you, if you are going to study well and you want to cover the lectures and that part, you might need to go through the presentations or the lecture materials I have done for the online class students in order to have the overall view of the module. So in this class, I think I will discuss with you regarding the interactive content that I have done during the interactive classes for the regular students. So apart from that, if I feel that I need to cover the theory parts, I will also do that. So if you are okay with it, just let me know. If you want in another way, you can let me know. Right. Another thing I want to emphasize, I think that now I think the attendance monitoring tool has been activated. Is it activated for you currently?
Miss, last week I couldn't mark the
You
attendance.
can check. Okay, it's
No,
okay.
teacher.
Today we will check today, I think. So I think it's okay. So ESP32 microcontrollers we have discussed so far, and we have discussed about the pin configuration of those microcontrollers. We have discussed about their specific functions and different applications. Different functions of the pins we have discussed. So voltage inputs, ground pins, analog to digital converting pins, UART pins, SPI pins, I2C pins, so touch pins. Uh, so those are some of the pin types and functions that are basically used mostly with the ESP32 microcontrollers. So touch pin is something that is not available in the uh, you know microcontrollers such as Node MCU, right? So when you take ESP32, there are some special functions that the ESP32 can do when you compare with the other microcontrollers. There are so many, differences, many differences with the ESP32 and the Node MCU microcontroller, I would say. So actually, voltage pins, ground pins, ADC pins, those are available in most microcontrollers. And also, I think UART connection pins, SPI connection pins, I2C connection pins are also um, available in some microcontrollers, and it is a function that is available. But this touch pin is something that is new in ESP32, and it is something that is new when you compare with the Node MCU. The Node MCU is a microcontroller that came before this ESP32 series. So before this version, there came another microcontroller which is Node MCU. So Node MCU microcontroller is also something developed by the same company. So uh, so it is a microcontroller that came before ESP32 microcontroller, and it is also something very similar to the ESP32. Um, However, when you take uh, the pin configuration and the different functions that the Node MCU can do, there are some differences. There are some things that Node MCU cannot do, and ESP32 can do likewise. So when you take the microcontrollers, some of the most important parameters will be that the microcontrollers have higher clock speed with the ESP32 than the Node MCU, right? So that means the data processing speed of the ESP32 microcontroller is higher when compared with the Node MCU one. Apart from that, the oscillating frequencies are also, defined. There are some defined oscillating, frequencies. However, the data processing speed is considerably higher in the ESP32 than in the Node MCU board. In the second week of our class, we have discussed about the IDEs, different integrated development, environments that can help you do the coding of the algorithms that you are going to embed in the ESP32 or any other microcontroller. So you need to have a certain integrated development environment or IDE, and you need to install that in your computer. So installation part of the IDE UPyCraft we have discussed in the class, right? So you can use UPyCraft, the IDE named UPyCraft, to develop MicroPython based code uh, for some kind of algorithm, right? For developing some kind of algorithm for certain task. So MicroPython can be a language that you're going to use, and MicroPython is a light version of the Python language. So MicroPython has lesser usage of memory, and also like it has similar functions to Python, but it is a lightweight version of Python. So it's similar as Python itself. So apart from that, there are other IDEs that you can use. So although I told you to install UPyCraft, you can also use Thonny IDE, VS Code, PyMaker IDEs, and those IDEs are also possible for you to install in your computer. So these IDEs also enable you to do the coding in Python, C++ languages. So C++ is the language that is used by experts to do the embedded system coding. However, in my class, I have asked you to do using MicroPython as well if you prefer. So when you are doing the project, IoT project, you can use MicroPython or C++. MicroPython is used by people or so I mean people who want to develop an algorithm without having much of programming knowledge. So C++ is something I think more advanced than Python, and it has more it has more syntaxes, and that may be one point that makes it difficult for us to develop some code. So as a beginner, I think you can use MicroPython to develop the code. So Thonny IDE, VS Code IDE, with some extensions, you can use these IDE to develop code for the embedded systems. Arduino IDE is also very popular. However, when you use Arduino IDE, you will notice that it consumes a lot of time for a certain code to run. So there's a high amount of delay when you are working with Arduino IDE, and also therefore you might not prefer using Arduino IDE. You might prefer using some simpler or less complex or lightweight IDE instead of using Arduino IDE. So right? If you have any questions up to that point, you can let me know. So apart from all that I have discussed, um, there's a there's this web page that you can use to install the different IDEs that you use to develop the code, right? So for doing the IoT project in this module also, you can use any of these IDEs that are mentioned here. So you can use Mu Editor, UPyCraft, Thorny, VS Code with PyMaker extension, PyCharm, Micro IDE, so and so on. So these enable you to develop the code in C++ or Python languages. So you will be able to develop the code for the microcontrollers. So the installation process is also given in this website, right? So the website I'm referring is this Random Nerd Tutorials. So in this Random Nerd Tutorials website, you can search for MicroPython IDEs. So if you like to develop using MicroPython, you can use these IDEs. I think that learning MicroPython is useful to you uh, uh, as a beginner as well. If you want, you can use C++ instead of MicroPython. So the steps of installation you can find in this website. So you can actually install the IDE based on the instructions given in here. So I think you installing the UPyCraft I have already done. So you have to install based on the given installation instructions. And after you install that, you need to run a certain sample code and see whether you can get the correct output that you expect or not. And then you can also check whether uh, you you can whether there are any uh, problems with the port that you are connecting your microcontroller, uh, right? So you can check whether you have any problems, errors coming in the serial monitor. With whatever the errors you are faced with, you can try to find the solution by searching in the internet, and also the manuals regarding that IDE. You can use PyCharm, you can use VS Code, you can use Micro IDE. So you need to install these softwares and you can select the type of IDE that you want to use. So after that, after you have the IDE, you can use the IDE for different development, algorithm development. So after I discussed about the IDE, I think I discussed about ultrasonic sensor during the class, and how ultrasonic sensor can be used to measure the distance from one object to another. From one place to the place where there's an obstacle in the path, right? So you can measure the distance to a certain obstacle using the ultrasonic sensors. So we discussed about the ultrasonic sensors. The in the LMS, I have given a certain certain code regarding certain assignment regarding your ultrasonic sensor based distance measurement. So I believe, I don't know whether you have completed that assignment. If you have any problems, you can let me know. If you have faced with any problems in the assignment, you can let me know during this class, right? So in the last class, I have discussed about the ESP Now protocol. ESP Now protocol is a protocol that is used for direct device-to-device communications. So in this protocol, basically you don't need an intermediate, micro any intermediate uh, uh, service provider, network service provider to uh, give the to connect your device to the other device, right? So without any network infrastructure, you are able to connect directly with another microcontroller, and you can get the information back from the other microcontroller. So this protocol has been, developed by the Expressive company, and this protocol is used and available in the Arduino IDE. So one of the libraries have been defined in the Arduino IDE specifically for this ESP Now protocol. So ESP Now protocol can be used in the Arduino IDE specifically. So I know that I have mentioned to you about Arduino about the Arduino IDE being late and being an IDE which is consuming a lot of time, right? Sometimes though, Arduino IDE has some libraries which are useful for us to implement certain protocols. So if we have protocols such as ESP Now, if you want to directly communicate or establish communication link with the other microcontroller, with another microcontroller in the nearby area, then we need to establish the ESP Now protocol using the Arduino IDE and the library related to ESP Now protocol. So that is available basically in the Arduino IDE. So so when you're using this Arduino IDE based ESP Now protocol, you are able to communicate directly. Communication is based on the Wi-Fi direct communication technology, right? Wi-Fi direct communication technology is the basis for this ESP Now protocol. So using that, you can send some short packet information or packets with about 250 bytes directly to the other device. Apart from that, fast communication can be done using this protocol. So when you're doing communication directly like this, you don't have to go through an intermediate device or some kind of a server that directs your communication to the receiver. Therefore, the delay in the communication can be reduced drastically when you compare with the standard communication methods. Then pairing is needed prior to the communication, right? Pairing is needed prior to the communication. That means that the two devices need to exchange some information regarding their status and regarding the time that they can initiate communication between them. So in the pairing stage, such kind of initial communication will be done between these microcontrollers, and the initial configuration that is needed to establish a data communication will be done or completed during the initial stage of their communication. So pairing is needed prior to the communication. After the pairing, we can do the data communication safely in a peer-to-peer manner. Peer-to-peer means directly from one device to another device. Peer-to-peer means like two devices which are in close vicinity, in close proximity. Right, two devices which are in proximity can do peer-to-peer communication. And there are different methods of doing such kind of peer-to-peer communications. One thing is that one device can directly communicate with another device, and that the communication can be in one direction only. If that is the case, it's going to be one-way communication. If that communication is also in both the direction, it will be two-way communication. And so it is a standard communication method. Apart from that, the communication can happen from one master device up to multiple slave devices, right? So the slave devices will receive multiple data, I mean, data that is transmitted by the master device. So one to many. So master sends data to all the slaves. So another coincidence, another incident is that master is sending data to the slave device, right? So there are multiple master devices, and the master devices are sending data to the slave device, which is a single device. So many to one communication can be possible. So so these communications are happening in frequency ranges which are unlicensed, right? So what I mean by unlicensed is that the communication frequency range is not in the range that is defined for normal communications, right? So what I mean by normal communication is that normally when we're taking a cellular call, then different frequencies are used for such kind of a cellular call communication. So there are defined standard frequency bands which are used for cellular communications. But if we consider this unlicensed band communication, then we are using the communication, or we are transmitting information using the frequency bands which are out of that licensed frequency bands. And so there are specific frequency ranges which are unlicensed. So in that frequency band, any device can use a frequency that they prefer. So that uh, frequency range can be a certain specific frequency range out of this unlicensed range, right? Out of this unlicensed band can be used by the devices to communicate. So when we are doing these kind of device to device communications, most of the time the devices will use such kind of unlicensed, or I mean undefined frequency bands, right, within the frequency range. So right, so unlicensed frequency range uh, frequencies are used for these kind of ESP now kind of protocols, right? Device to device communications. So basically, ESP now is a protocol that is used for ad hoc wireless networks, right? It is a protocol that is used for ad hoc wireless networks and to establish the communication between ad hoc devices. So what I mean by ad hoc devices is that this communication will be established between devices which are not connected to the network infrastructure, to the standard network infrastructure, such as the cellular towers, right? Cellular base stations, cellular networks, right? So these devices are not connected to the cellular network. These devices are working, operating on their own in a standalone manner outside the cellular network. So outside the cellular network, they are working in ad hoc wireless network, and that ad hoc wireless network, in that ad hoc wireless network, the devices can use direct device-to-device communication technologies. Those technologies can include one technology that can be used is ESP now protocol-based technology. So that is basically regarding what we have discussed about the ESP now protocol in the last class. So ESP now protocol can be implemented in reality using two ESP microcontrollers, and you need two microcontrollers to implement the ESP now protocol. When you go to the this website, you can see random. This website is called Random Nerd Tutorials. You can go and search for ESP now protocol, and you can get information regarding that protocol. So this website is useful in that sense because it shows you the real world implementation of the protocol. So you can go through this web page. I have given this link to to this web page in the LMS as well. If you want, you can go through that and you can understand how this can be implemented in a real scenario, right? So the first thing that you need to do is that you need to get the MAC addresses of the ESP microcontrollers. Right? So the MAC address is the unique address that is defined for each hardware, right? So each ESP32 microcontroller, there's a specifically defined MAC address, and that is unique for that certain microcontroller. So you can use a certain sample code inside the IDE of the IDE that you are using. And you can use this sample code to find the MAC address of the specific microcontroller that you're using. So you can find the MAC address of the two microcontrollers that you're using separately, and the MAC addresses will look like this. The MAC addresses will be separated by certain numbers with double colons, right? So the MAC address you can find for each of the device that is doing the ESP now protocol, right? So once you know the MAC address, it makes it easy for you to transmit the information directly to the other device with a certain MAC address. Right? So I hope it is clear to you. So after you have found the MAC address, you need to run a certain code in the transmitting device, right? And then you can use this code, and then you can try to see what it does. Then you can try to send some information from this device or microcontroller to the other device. So the first thing that in this example that they're doing is that they are creating some data, right? Data, my data.b, my data.c, my data.d, right? Those data to be sent to the other device, right? So the my data is something that they are sending to the other device. So anyway, right? So if the uh, right, so we can use this ESP now send command to send the data, right? To send the data, and if the data transmission has happened successfully, there will be a message sent like this, sent with success. So a message will appear saying sent with success. If it is not sent properly or reliably, there will be an error message or saying that error sending the data. So that is basically how it will function. So you will basically need to use this ESP now send function to transmit the information messages to the other device, right? So once you know the MAC address, you can send the data directly to the other device, and there's no problem of sending data uh, once it is uh, working in this manner, right? So you can go through the code and you can try to understand how the code works, and then you can try to implement that in one of the ESP microcontrollers, right? So one can be the transmitting device, other can be the receiving device, right? So for the receiving device also, we have certain code that we can uh, develop inside the microcontroller. So ESP32 receiver sketch gives us that code. So in here you can see the code that is used for at the receiver, and then at the receiver you need to uh, type this code, and this code will uh, will enable you to type the or print out the information that is received from the received message, right? So you can decode the message and you can print out the different messages that are included in the data received. So this is the kind of the code that can be used to do that. So if you have the ability to do these activities, I encourage you to do it. So if you want to do these activities, you need to have ESP32 microcontroller. And also, if you are going to do ESP now protocol, you need to have two microcontrollers. So for transmission and reception of the data. So if you have those components, I believe it will be easy for you to complete the task. If possible, get into groups with your friends and ask them also to contribute to the work. Uh, so up to that point, I think that is basically regarding ESP now protocol, and you need to just implement the codes in both the devices. After that, you need to try to test the ESP now communication method, that you transmit some data at the transmitting side, and then it should give a message saying delivery success or sent with success. Likewise, there should be some output message. Apart from that, at the receiver end, you will have to see some message like this, which shows that data has been received, data have been received at the receiver end. And then, so these are kind of the messages that you can see once you, once you once you implement, and right, once you implement successfully, you will get some data at the receiver end, and it should look like the one that I just showed. So basically, once you build the codes in both the microcontrollers, you can get the communication set up, and you can check the communication quality by printing out messages in the code, right? That says delivery success, post entry success, those things. So once those messages are received, you will know that the message has been received successfully. So these are the messages that have been received at the receiver. And using those messages, you can find out more information regarding the information that was transmitted, right? You can send different data apart from this project. Now in this website, they have given some data to transmit, right? But instead those data, you can send your own information. You can put your own string value in here, and then you can test out whether the same message or similar, corresponding message is received or not. Apart from that, we discussed in the last class about the different IoT protocols that are used in the IoT networks, and some of the protocols are used specifically in the IoT scenarios. And I believe that we discussed about some of the protocols in the last class in general, kind of in a global sense. So today, I think that we will have to discuss about these protocols further to get a good understanding about the protocols that are specifically used for the IoT networks, and that will help us implement the IoT project also. And the IoT project, in the IoT project that I have given, you are asked to develop MQTT based communication. So MQTT is one of the protocols that I use for IoT. So I think started discussing about that in the last class. The MQTT protocol is something that you will need to implement in the project. That is something, I think, that is something that you might need to do, and therefore I think I will explain to you how you can implement the MQTT protocol in the real world. Right, for that also I have given some reference links as well, so we will discuss about that as well, right? So we will discuss about the protocols, right? So about the protocols we will discuss a little bit. I actually um I want to know, like, what are the protocols that you want me to explain further, right? I think I will anyway explain about the MQTT protocols, EOAP protocol, HTTP, and other application layer protocols. But I actually cannot really, remember. I'm not sure about whether I have covered these protocols like 6LoWPAN, and I'm not sure whether I have done this or not. So can you please let me know whether I have discussed about protocols up to transport layer so far? Can you let me know if you can remember?
So actually, this network layer functions we didn't discuss.
Network layer protocols. Okay, physical layer ones did I discuss? Physical and
I,
data link
I
layer.
think that is also didn't discuss me.
Okay, right. So I think then I will explain like theory about that, right? And then I will get into the all the uh, I mean, I will get into how we can implement like a scenario or a network with using those protocols. So thank you for letting me know that, right? So I will try to explain one by one about those protocols. So one thing I want I want to know is that Like for the regular students, I'm doing theory class. So you want me to do the theory as well in this class and do both the interactive class and the theory class. So initially, like I think one of the students told me that they can follow the online class, and then I just need to follow the other part only in here. But I just want to know whether I want to do both in here. So if you can let me know, it would be great.
Miss, is it during daytime? No.
Online class I'm doing normally on Tuesdays 11 a.m.
Yeah, Miss. Actually, I have difficulty to join because I'm working at that time.
Yeah, so yeah,
Me,
that is
me
the
too,
thing.
miss. We are working at that time. That's the reason.
Yes, so I think that uh, I understand that. And do you have time to go over the online sessions during your free times? Because you need to, I
Yes,
think, go through them.
if you can upload, we can go through the videos.
Yeah, I have uploaded the videos. I think for the regular students, whatever I have done already is uploaded there. Uh, right? So it is already
Okay.
uploaded there. So you can watch those videos whenever you have the time. So you have watched them, I think that I have covered like the things that I'm discussing over here, right? So basically the protocols related to physical layer functioning and uh, physical layer, protocols, network layer protocols, transport layer protocols, and application layer protocols I have already discussed in the online class. So I think because you did not have much time to look at or refer those, lecture materials, you might not be able to follow up that quickly with what I'm saying. So if that is the case, I think I will give us like a maybe 5 to 10 minutes brief introduction about what I have done in the regular class, and then I will explain to you like the interactive class content afterwards, if you're okay with that, right? So I think that in the like in the previous classes, I will show you like I will also try to upload the like I mean I have already uploaded the videos, right? Videos of the sessions. I will also uh, share with you the notes as well. So these are the sections that I have covered under the uh, IoT. Initially, these are the sections that I have covered. Initially, I have covered sections related to the hardware of the IoT, basically the sensors that you need and the microcontrollers that you require. So these are the microcontrollers based stuff that I have discussed. So have I discussed with up to this point? I have discussed with you, I believe. Up to this last, hardware controller boards I have discussed. Is it okay with you? I have discussed like that, right? To the hardware microcontroller boards and different types of boards. Are you okay with that?
Okay, miss.
Okay.
Yeah, I think
Miss, in the
Ratnayaka was there. Yes.
yeah, yes, Miss, excuse me. I have a
Oh.
question. In
Mm-hmm.
the first assignment, there's a question to compare both
Mm-hmm.
Node
Mm-hmm.
MCU and ESP32.
Yeah.
Uh, do we have to compare the microcontroller or the development board?
Development board actually. Development board. So you're asking about the chip.
Yes, so do we have to compare the whole development board or microcontrollers only?
So actually the whole board, I mean whole
Okay.
board with the different pins that are there, like
Okay.
as the um, I mean pins that we can use for different tasks. So so this will include not only the chip but also the other features in the board. So if we consider this node MCU, there's some kind of a chip. The chip is there. Apart from that, like there are some processing power, right? There's some processing power, the data processing rate, clock speed, some kind of pins, right? There are different types of pins and different numbers of pins. Um, and there are different connections that can be enabled into the hardware controller board. So those things are the ones that I wanted you to compare. I believe that I have given you the factors also to compare with, I think, for both the boards. I can't remember exactly. I have given you like specific factors that you need to compare for both the
Yes,
boards.
yes, yes. There was.
So you can consider those factors for the entire controller board, and
Okay.
that is used. Yes.
And one
So
more thing is, can you explain, Miss, the assignment number one question? Uh, I I can't
yeah,
understand about the question number one.
assignment number one. Okay. Yeah. So I think this is about uh, like trying to label the different units that are basically in a certain IoT product, for example. So what is the thing that you can't understand?
Means when we search certain products,
Mm-hmm.
we can't find out things like processing unit and
Mm-hmm.
whether they have a storage and the Wi-Fi connection is mentioned in almost all the
Mm-hmm.
uh, products.
Yeah.
But means communication unit, uh,
Communication means the Wi-Fi, no?
then means the localization system. What does it mean? Can you explain?
Yeah, so localization means like whether there are some kind of GPS systems that are used to find the position of the device, the
Ah,
IoT device. If there are,
okay,
I mean, if it is optional, sometimes there might not be, that most of the devices might have it. If they have it, you can label it.
okay. Means
Yeah. The
what
processing
does
unit and the storage unit. So you can just point out to the chip or main processing uh, chip most of the time that does the
means
processing.
for uh, most of the products they have not mentioned in the specifications
Mm-hmm.
about the processing unit.
Mm-hmm.
That's the reason. Uh,
Uh,
and I want to clarify about the mobility module also.
Mobility module. So that means like something related to the dynamic movement of the device. If the device has some movement, if that movement is there, then what is the um, kind of module that enable that movement? If there are wheels, for example, the wheels are maybe controlled by some kind of module, some kind of motor or something, right? Some kind of motor or something that enables the mobility of
So we
device.
can we clarify it under activation unit means actuation?
Yeah, actuation also, yeah, related to motors. Mobility module is also about motors, but it is about moving, how the device will move. So any related components, all the related components related to the movement, you can just point out by like maybe highlighting all the areas related to the mobility.
Okay, thank you.
Miss,
Okay.
that means some products is includes the GPS in embedded with embedded module. Likewise, we want to search that products and categorize them as a like a table.
You just go have to take the image of the product, and in the product you need to label the components. You need to, if possible, take a very clear image that shows the individual components of the product, right? Right? You need to take a
Okay.
clear image. Then from that you can label out, okay, this is the localization system, and this is the mobility module related parts. Likewise, you might need to use the image itself to uh, point out the different components. You can label them as 1, 2, 3, 4 something, and then maybe you can list them out in the bottom, right? If it gets messy or something. But what I want you to do is take a real world image or picture of the device, and if you can find the device picture with all the interior parts also visible, then that will enable you to like label out the different components separately and show different parts of the device, right? So that is my my expectation. So when you're choosing some certain products to label, you might need to check whether you can find the interior architecture or the interior look layout of the device as well. Sometimes if you just have the covering of the device, you might not be able to do the labeling. You need the interior like picture of the device as well. So if you can find a real device, you can take a photo of it. Not, you can Google search, and then you can use that image, and by the help of that you can do the labeling. uh, I hope it is clear. So it's okay right now.
Yes, Miss. Thank you.
So okay, what else? Do you have any other concerns?
Miss, is this deadline is today midnight or tomorrow midnight?
I think today midnight, I think. No, tomorrow actually. Tomorrow. I can't actually. Let me check. So yes, it's I think today midnight.
Miss, can you please extend it to tomorrow midnight? I am
Uh,
in the middle of doing the assignment.
okay.
Yeah.
Mm.
It's a little bit hard to find about the two boards, comparing two boards.
This is the first assignment, no? This one you can submit by today, right? Have I asked something else in that? I have given another question. Okay.
Yeah.
Okay, I will give you time until next tomorrow midnight. So
Thank you very much.
okay, so no problem. So submit to this link, and think it is okay now. Think yes. Um, right. So assignment one, that's it. So about any other problem? Do you have any other problems regarding other assignments or some things? If you have any problems, you can let me know. Um, right. So again, I think you will ask for another deadline extension by this weekend, right? Sunday there's another deadline. So if you want, I don't
Actually,
know.
Miss, we did that partially. We
Uh-huh.
did that
Uh-huh.
that
Okay.
one. Yeah.
Uh-huh. Then okay, then that's good. Okay. So actually, I will proceed to this. If you have any questions, you can just proceed. The microcontrollers, I believe we have gone through some of the factors regarding the microcontrollers. And these microcontrollers, like basically all of them have certain different, uh, you know, characteristics and different, I mean, performances. Basically, based on the performance, actually we buy the microcontrollers most of the time. So when you talk about Arduino, for example, Arduino has like uh, has is most popular one, but it has some kind of problems related to the memory. Memory space is not enough. Because of that, we might not be able to store a lot of codes and data into the Arduino. So although it has many functionalities and it gives us a lot of libraries to work with, there is some limited space in the Arduino IDE. So sometimes that can be the reason for not choosing to buy this. And it has a clock speed of 16 megahertz. So data processing speed is determined by the clock speed. When you talk about the Node MCU microcontroller board, you have different functionalities enabled in that one. And when you talk about the data processing, there are two cores. So dual core processing is enabled in here. So you have two cores to do the processing. So the processing is much faster, and you have basically Wi-Fi connection and other I mean communication technologies so enabled in this one, which you have to actually refer the data sheet properly to understand all the different functions enabled in this microcontroller board. So this has similar, performance to, I mean, Node MCU has a similar performance to ESP32 microcontroller as well. ESP32 is something that we are using most of the time in our IoT project, and therefore I think it is something that is familiar to us by now. So ESP8266 microcontroller is something that came before ESP32, right? So there are some functions and different functions of this ESP 8266 microcontroller. However, like once you consider about the ESP32 microcontroller, it has several advantages over the ESP. I mean, the previous one that I did just discuss. Some advantages are there. I mean, in terms of data processing power, dual core processing power is anyway there in both the two cases, in both this one and this one. There are they both have dual core processor, but one advantage here is that there are more pins in this ESP32 microcontroller compared to the previous one. So this has some number of pins, but the micro ESP32 has more pins. Apart from that, the ESP32 microcontroller, this microcontroller has the Wi-Fi connectivity, Bluetooth connectivity. Therefore, you can actually work with a lot of libraries, and you can access the web resources very easily with this microcontroller. ESP32 microcontroller, both of them have Wi-Fi, right? So they both have the ability to connect with the internet. So that is something that it enables them enable them as, or they are considered as very powerful microcontrollers because they are because of their ability to connect to the internet. So once you connect to the internet, you can get enough resources from the internet. So it's like creating an Internet of Things network. So although the device might not have many resources in the device itself, it might be able to get the information from the internet. So this this ESP32 microcontroller is very cheap when you compare with the other microcontroller devices, but it has the functions of Wi-Fi connectivity and data processing that makes it more popular with the crowd, because it does the main functions that are required from a microcontroller. When you talk about the Raspberry Pi microcontrollers, it has more functions than ESP32. Speed, higher clock speed, 1.2 megahertz clock speed, more data space, 1 GB RAM, and many interfaces such as HDMI, USB, Ethernet, onboard Wi-Fi, Bluetooth connections are available. So, uh, I mean, there are many advantages of using Raspberry Pi, but it is more costly. When you're trying to buy this one, it is costly. So therefore, although this is like available in the market, people sometimes fear buying this one because of its price, and they tend to use ESP32 microcontroller sometimes to get the work done. So when you compare with the ESP microcontroller, Raspberry Pi has more clock speed, right? You can check about the memory space as well. I think Raspberry Pi has more memory space than ESP32, and the activity and many large algorithms can also and image processing algorithms also in a Raspberry Pi model. So and then we started discussing about, I think we lost the connection for some time. So to up to that point, we discussed about the hardware, hardware controller boards, microcontroller boards, which are used for IoT networks and which are used for developing certain algorithm and the IoT devices, right, that we are going to use in our IoT network. And then we are going to place them in certain remote areas. We are developing the code in those embedded systems, right? So after you develop, and once you're trying to transmit the data, right, you need to use different communication technologies, and you need to use different network layer protocols, transport layer protocols, and application layer protocols to transmit the data to a certain. Okay.